Guys, lesson 5.5 takes us to our, I don't know, next to last set of identities. I don't even know if I'd call this identities, but we're talking about the law of sines, okay? Back in chapter 4, we talked about SOHCAHTOA, right? Sine, cosine, tangent. And we could use sine, cosine, and tangent to find missing sides and angles when we are in right triangles. Okay, but sine, cosine, tangent only work for right triangles. What we're learning, both in this lesson and the next lesson, apply to all other triangles. Okay, so law of sines gives us ways to find missing sides and angles for non-right triangles. Okay, so this reads, in any triangle ABC with angles A, B, and C and opposite sides A, B, and C respectively, the following equation is true. Now, you guys know the basics. Capital letters are your angles. Lowercase letters are the sides, right? Okay, and keep in mind, now, like for instance, this side right here that's marked C, we could, if we wanted to, call it side AB using the endpoints, right? But for ease, really, we're just going to refer to it as side C. Now, why is this side C? It's side C because it's opposite angle C. Does that relation sound familiar? Okay. Side A has to be opposite angle A, and side B is opposite angle B, right? That's old news, going back to geometry, but just reminding you. Okay, what we have that's true is this set of ratios. The idea that sine of angle A divided by side A is equal to sine of angle B, which is divided by side B, and it's also equal to sine of angle C divided by side C. These are interchangeable, folks. You can pick any two of these three and set them equal to each other and create an equation. So it's not that we're going to be setting up some big, long, funky equation with three parts. We're just going to be picking 2 out of the 3 at a time. So as long as you know 3 out of 4 pieces of information between 2 of these fractions, we'll be able to use them, okay? And again, once we look at our first example, these will make more sense. Now, back in geometry, do you remember AAS, ASA, SAS, SSS? You learned those back in geometry. Things like angle, angle, side, angle, side, angle, side, and side, side, side. Those were, I don't want to use the word theorems, like congruence theorems. Okay, the idea that if all 3 sides were the same in 2 triangles, then those 2 triangles were congruent. If you had a angle, side, angle, so like the idea of angle, side, angle. If you had an angle, side, angle that, falls in line, that could make 2 triangles congruent. Things like that, okay? Well, these apply to law of sines and law of cosines when we get there. But we also now get to introduce angle, 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 and side, side, angle. These were 2 you didn't get to use in geometry because they don't work for triangle congruence, but they do work with law of, those are both cosines. Okay, now, specifically today, law of sines. We have angle, angle, side, angle, and side, side, angle. So if we have a triangle, given those 3 pieces of information, whether it be an angle aside, an angle, side, angle, or a side, side, angle, we can find missing information. Okay, we can use law of sines. Law of sines will apply. Okay, so let's look at example 1, easiest way to get us in here. And example 1 talks about solving triangles that either have an angle, angle, side setup or an angle, side, angle setup. So basically we're looking at examples where 2 angles are provided. Okay, so this example, and with these 2 setups, you'll always get a unique solution, meaning there's just going to be 1 set of answers. Okay, we'll talk later in the lesson about when you might have multiple answers, but there'll just be 1 set of answers, and it's basically, as I said, when there are provided 2 angles. So our example with 2 angles, they're asking us to solve triangle ABC, so finding all missing sides and angles, given that angle A is 36 degrees Angle B is 48 degrees, and side A is 8. Okay, so notice they gave us angle A, angle B, and side A. And if we go back up to the top real quick, notice, what did I just say? They gave us, what was it? Angle A and B and side B, if I recall? No, side A. There we go. If you look at those 3 pieces of information they gave us, this is a scenario of, we could say, side, angle, angle, which isn't really in our list, or reverse it, angle, angle, side. Okay, so we're looking at an angle, angle, side scenario is what we're looking at. Again, 2 angles are provided. So, let's look at what we have and figure out what to find. So we know provided, what do we have? Angle A is 36 degrees. Angle B is 48 degrees. In terms of angles, that means we're going to have to find what? We're going to have to find angle C, right? So we're given angle A and angle B. We're going to have to find angle C. We were also given side A, which is 8. And that means we're going to have to find what? We're going to have to find side B and side C. Okay, so right there, not that you necessarily had to write that down, but I'm just trying to get you guys to think, okay, this is what we know, this is what we need to find. We know 2 of our angles, we need to find the third. We know one side, we need to find the other 2. Now, sometimes you have problems where you have multiple different directions you could go. Because technically we have multiple different directions we could go here. There's 2 different ways I could start this problem, but let's go with the easiest. You don't have to know anything about what I'm teaching today. Old news. What do we know? Okay, we can find angle C because the rule is all 3 angles in a triangle always add up to be 180. Okay, so that still applies. That's still going to be your way to find the third angle usually. Okay, so I'm going to write this out as angle A plus angle B plus angle C equals 180 degrees, or in other words, 36 degrees plus 48 degrees plus angle C equals 180 degrees. I'm not going to show any work or do any solving there because you guys already did it on the calculator. What is angle C? 96 degrees. Okay. We got the basic math out of the way, right? That even goes before geometry. Is that like middle school math? No, does it go back to elementary maybe? I don't know. Okay. Now, so we officially have all of our angles. Now the deal is we have to start finding our sides. In order to find sides, we're going to talk about law of sines. Okay. What set of information do we already know? We already know what?
The sine of angle A, 36 degrees, divided by side A, which is 8.
Okay. We already know our A's, yes? We know angle A, side A. So we can set up that piece. And then what's another piece of information we know? What was the other given? We were given angle B. And what can that help us find? What can that help us find? Or think about it this way. Okay, if you go back to, there were 3 parts, right? Sine of A over A, sine of B over B, sine of C over C. The one part we're going to have to use is sine of A over A because we know both the A's. Now, we know angle B, yes? So let's use sine of B over side B. We know 3 of those 4 pieces of information. So fill them in and let's do some math here. So sine of A, I'm going to fill in. This is what Angela was talking about. Sine of 36 degrees divided by side A, which is 8, equals sine of B, which is sine of 48 degrees divided by B. I don't know it. I don't know little b. How do we solve? This is algebra here. We're solving.
Get the b out of the denominator.
Okay. What method do you guys use to get the b out of the denominator? Okay. So what do you say? Multiply the b to the other side? And then what?
Divide by the sine of 36 over 8.
Okay. So this is what my morning class did too, and I'm gonna throw out cross products is what I'm gonna throw out. But here's the idea. Do you guys have the fancy dancy calculators too that you can do all the fancy dividing? You do. So she's saying multiply the b, and then you divide this fraction over. So she's saying sine of 48 divided by sine of 36 over 8. It works. You have the fancy calculator you can put it into. I personally always teach cross products here. I'm not saying you guys are wrong. I'm not saying I'm wrong. Okay? They're both good ways to do it. So do you guys remember cross products? Where it's the diagonals? B times the sine of 36 degrees is equal to the other diagonal, 8 times the sine of 48 degrees. And then, how do I solve for B? If it's B times this, I'm going to divide. So mine, when I put in the calculator, is going to be 8 sine of 48 degrees divided by sine of 36 degrees. Now, everybody sitting in this room is required to pick up their calculator and input this information. So if you haven't already picked up your calculator and practiced, please do so. Does your answer match my answer? FYI, I'm expecting some no's. So if you're afraid, because I see some people kind of frantically looking at their calculators like, what did I do wrong? What's the catch, guys? Has anyone figured out the catch? You have to be in degree mode. No, I'm expecting some no's. Why do you think I said everyone needs to pick up their calculator and practice this problem? Because what mode does your calculator need to be in for pretty much the entire homework? Degrees. How did we know degree mode, or how should you know degree mode here? Other than your answer doesn't match my answer. What tells us degrees in this problem? My angles were given in degrees. There's your clue that you need to be in degree mode when punching things into the calculator. Fair enough? Okay. This is why I want everyone to pick up the calculator. Maybe it's not the same calculator you use to do the homework, but at least you've had that mental of, oh, got to check my mode. So, I think in my notes I have 10.11 written down on this one. Although, after I get, this is the only homework, or the only problem I wrote down 2 decimal places. Most of the problems I was writing down 1 decimal place. Are we good with this now? The calculator's good? Okay. Now, we found angle C. We found side B. Now what?
Do the same thing, but solve for side C.
Okay, do the same thing, but solve for side C. My recommendation here is going to be that you still stick with using the A's and set it up with C. So my recommendation is going to be sine of A over A again, but this time we're going to say sine of C over C. Now, with that in mind, could you use B's instead of A's? You know B's now, don't you? I'm going to caution you though. What would be my hesitation with using the B's? Side B is a rounded answer. So if you use side B here, you're going to get a slightly different side C answer. My recommendation is always go back and use the original information that you didn't have to round whenever possible. Okay? Just because then we don't have to argue about whether your answer is correct or not. Okay, so again, it is still sine of 36 degrees divided by 8. Sine of, what is C? 96 degrees divided by side C. Cross products again, or whatever method you use. I'll show my method. Make sure you meet me in the end with your correct answer. What are you guys getting on this one? Mm-hmm. 13.54? Yes? Okay. The catch on the calculator is make sure that your calculator is in, I start to say angle mode, degree mode. Okay? Okay, questions I need to cover on this one. We're good on this one?
So we'll just be trying to will it have like a specific side that we're trying to find, or?
They would usually, well, usually you find all the missing sides and angles. Yeah, so most of the time, I don't remember the homework for sure, but most of the time in a log sine or log cosine problem, they don't let you take the easy way out and say find side C. They say solve the triangle. And solve the triangle is fancy speak for saying find all the missing pieces. So, yeah, plan on finding all the missing pieces. Okay. So that was an example of when they give us two angles. When they give us two angles in either the angle side or angle side angle setup, it's pretty cut and dry. Okay. Now, we found angle C first. Technically, we could have found side B first and then angle C. The only thing we couldn't have done right off the bat is we could not have found side C right off the bat. You have to have angle C before you can find side C. Okay? Now, example 2 takes us into a specific case, the side-side angle case, or what they call the ambiguous case, because depending on the relationship between the numbers of the side-side angles that you're given, there could be one triangle, there could be two triangles, or there could be no triangles. Okay, so it really kind of depends on the numbers and how they relate to each other. So I'm going to talk about these, and this right here is kind of the general situation, okay? Where, say, we're given angle A and a side C and a side A. Are those always the pieces you're going to be given? No, okay? But this is the connection we're looking at, okay? So say you're given an angle A, a side A, and side C, okay? Here's your different scenarios. If angle A is given to you as obtuse, and side A is bigger than side C, you will have one triangle possible only. Okay, so if angle A is obtuse, and angle A, so the side opposite the given angle, is bigger than the other side, you have one triangle. You would have no triangles possible if the side A is smaller than side C. And here's the deal. Do you guys remember the basic idea that if angle A is the largest angle in a triangle, then what do we know about side A? It's the largest or longest side. Do you guys remember that connection? If you have the smallest angle, then that's going to be opposite the smallest side. Okay, so this idea here is that if A is obtuse, it has to have the longest side. There's only going to be one obtuse angle. So that side across from it has to be longest. Okay, now we have two acute options. If angle A is acute, so if this is an acute angle, but C is bigger than A, so the side next to it is bigger than the side across from it, then there are two triangles. One where this angle C is obtuse and one where this angle C is acute. That's a tough case to figure out. We'll go through an example like that at some point. Okay? And then the other option is if angle A is acute and A is bigger than C, then you have one acute triangle. Okay? So those are your different options depending on what is given. Between examples A and then B and C on the back, we're going to work through each of these types of examples so you have an idea of what they look like. Really, though, using a lot of the skills we've already looked at and adding a few more. Now, you'll notice it says the best way to determine which type of scenario we have is to sketch a triangle with the given information. And I know easier said than done, but I will often try and sketch a triangle to help us have a visual. So in example A here, it asks us to solve triangle ABC, given that side A has a length of 7, side B has a length of 6, and angle A is 26.3 degrees. Now, realize, is it always going to be triangle ABC? I'll be honest, we're going to see that a lot, but does it have to be triangle ABC? No, it could just as easily be triangle XYZ. Okay. With that in mind, what I want you to realize is this information that was given right here was based on if you were given those three pieces of information. We won't necessarily be given A's and C's. For instance, in this problem, we're given A's and a B. So you can't rely exactly on this triangle setup. And we're going to set up our own. Now, I'm going to draw a triangle that has a small angle A. There's not one right way to draw it. And I don't even know that I got that small enough, but that's my triangle right there. I'm going to put A on that left corner, and A is supposed to be 26.3 degrees. We know side A has to be across from it, and it has a length of 7. Now, in terms of side B could really go either place. In my brain, B is about the same length as A. I'm putting B over here personally because those two sides are about the same. In all honesty, B can go either place. Okay? Now, if I put side B here, then that means angle B has to be there, which leaves the top angle to be angle C, and that down here to be side C. Okay. Let's look at what they provided. Notice we were given an angle, a side, a side. So going around the triangle, we were given an angle. Okay, I'm going to reverse that though, because they refer to it as side, side angle, right? So, side, side angle. Okay? With that in mind, I'm trying to help us figure out which scenario we're in here. Angle A is given to us as acute, right? So angle A is acute, and it doesn't even have to be angle A, but we were given an acute angle. And then what do we know about our sides? Side A is what in relation to side B? Side A is given to us as bigger than side B, yes? Okay. What I'm going to take you guys through, okay, angle A is acute. So if angle A is acute, we're either in Option 2 or 3, right? It's either here or here. Now, angle A is acute if side A, so the side opposite the given angle, is bigger than the other given side. That's this scenario right here. Side A, the same one as the given angle, is bigger than the opposite side. We're just looking at one triangle is what my point is. Okay, all that information, and I'm just trying to get you to realize we're just looking at one triangle. If angle A was acute, but it was the smaller side, it had this, A was the smaller side, then we'd be looking at two triangles. Okay? Now, from here, folks, same idea as last time. We need to find our missing sides. Okay? We don't have to worry about two triangles. There's just going to be one. So we have angle A. We have to find angles B and angle C. We have sides A and B. We have to find side C. What piece of missing information must I find first? I only have one option of what I can start off finding on this problem. We have to find angle B. Because we know our A and A, right? And we know side B. We have to find angle B. That's the only option I have to start with. So, similar to what we did last time, I'm going to start off as sine A over A equals sine B over B. Fill in what you know. Sine of 26.3 degrees over 7 is equal to sine of B, because that's what I'm looking for, over side B, which is 6. Okay? Can you do the math to solve your equation? I'm personally going to do cross products again. I'm going to say my diagonals of 7 times sine of B is going to equal my diagonal of 6 times sine of 26.3 degrees. How do I solve for sine B? We're going to have to divide by 7, right? So right now I have sine B equals 6 times sine of 26.3 degrees divided by 7. Okay. How do we solve for B? Inverse? Here's the deal, guys. First of all, let me answer the question some of you guys were thinking about. Can we just divide sine and B apart? I wish it was that easy. Sine and B are attached. We can't just divide them apart. But if you recall in math, you remember switching your input and your output? What will allow us to take our input and our output and to switch them? Or it might be easier if I ask about if we're switching our x and y. What allows us to take our x and our y values and switch them? And that is your inverse function. Okay? Remember, sine, cosine, tangent, all these trig functions have inverse functions. And inverse functions are going to allow me to take my input of b and my output of this fraction and switch them. Okay, so that's your inverse function. Now, so I'm going to write this, so I'm going to switch these pieces. I'm going to write this as b is the sine inverse of 6 sine 26.3 degrees divided by 7. And then I need everyone trying this on the calculators, folks, because I know some of us don't remember the calculator part for this. So everyone grab your calculator and see if you can remember how to do sine inverse. Do you remember how to do sine inverse? It's not difficult, but sine inverse, remember your inverse functions are the second functions, right? So you're going to do second sine, and that pops up the sine inverse option. And then just type your stuff in there. Should still be in degrees, because we want our output to be an answer in degrees. I don't want an output in radians. Does your answer match my answer? Is my answer right? Yeah. Okay. As I said, I just have one decimal place on most of this lesson. I'm guessing that means homework is one decimal place. I haven't looked it up today, but so I have this written down as 22.3, and it'd be 22.3 what? Degrees. Okay, questions there? Okay. We found angle B. We're not done. It says solve the triangle, so what are the missing pieces? We were given A and A, we were given B, we found the other B. Okay, I have a direction I have to go next. What must I find next?
C.
Which C?
Angle.
We have to find the angle C first, don't we? And how do we find angle C? All three angles in a triangle always add up to be 180 degrees. So set it up and do the math. Angle C is 100 something, that's all I remember.
131.38.
Okay. I have mine rounded as 131.4, so equivalent. Okay. So angle C is 131.4 degrees. Now that we know angle C, what can we find? Side C. Officially, I'm still going to recommend you go back and use A's. Granted, technically angle C is a rounded angle because angle B was a rounded angle, but I'm going to recommend, safest bet is go back and use A's because that was the given information, and then now pair it up with C's. So sine A over A is equaling to sine C over C. So sine of 26.3 degrees over 7 equals sine of 131.4 degrees over C. Okay? Do your math however you want to. Now, here's one thing I'll say about homework, or more importantly, chapter test. A page full of answers is not going to cut it. Don't try and bring me a page full of answers on homework and say, here you go, because I'm not going to take it. Okay? Should I see some work? Yes, I should see some basic work. Do you have to show all the steps I'm showing? No. But you've got to at least show me an initial setup and go from there. Okay? So I know I'm going to do cross products, and I don't even always show all my pieces, but so Cross product C times sine of 26.3 degrees is equal to 7 times sine of 131.4 degrees. Realize this is just back to a basics, isn't it? No fancy inverse here, so 7 sine 131.4 degrees divided by sine of 26.3 degrees. And put it in the calculator and go. What are we getting? $11.9. Okay. So, of our ambiguous case, our side-side angle, this was option 1. Okay. This is option 1 where we were given an acute angle, and the side opposite that angle was the bigger of the two given sides, so there was one triangle. Okay? Now, when you flip to side B, they're going to give us a new set of information, and we're going to look at that. So, as we look at example B, notice it's asking me to solve triangle ABC again, so that's going to be find your missing sides, given that A is 6, B is 7, and A is 30 degrees. Now, scenario this time, and there's already triangles set up here on purpose. They gave us angle A, they gave us side A, which is 6, and they gave us side B, okay? Notice what happens this time. An angle, and then this time across from the angle is this smaller of the two given sides. Well, guess what, guys? You can probably already guess based on what you're seeing. But they give you an acute angle, and the side opposite it is the smaller side. Guess what? This is our scenario where we have two triangles. Okay? Now, because I can never draw these triangles to save my life, I put them in here for you. Okay? Because I can't draw them. And then you guys trying to copy my poor drawings just makes it even worse in your notes. Okay? So, what we're looking at here is we're looking at the first example, which is this triangle right here. Okay? That's going to be your basic triangle. You're going to be doing exactly what we've done in the last two problems. You're going to know the steps to take. Okay? However, there's also another option here. And the other option here is taking, this dotted line represents the whole big triangle, taking that whole big triangle, moving that side length 6 over, I can't even trace it right, geez, and making it that skinny little triangle. Okay, so in other words, that side 6, what that side 6 can do is it can fold under here, and because it's smaller than 7, it could be underneath there, and it can also, those three lengths or measurements can make this small triangle. So what we're going to be working through is how to find those two pieces. Here's what I'm going to suggest you do, because I'm kind of in awkward timing. See if you can figure out a first step based on the given information here. Doesn't matter that there's going to be two triangles. Fill in your first step here, and we'll start with that tomorrow. Okay? Just leave room down here below to try and do part 2, because we'll also have to do part 2. But we'll pick up there tomorrow. but see if you can find at least one piece of information. Actually, you can probably do all of the first triangle, really. Okay? So at least try and find one piece of information here, though, before you put your notes up. And we'll pick up there tomorrow.